Hello colleagues, welcome back to my YouTube channel. During our previous class we discussed vacuum circuit breakers. You can also check out the video through the link in the description box below. Now stay tuned, let us explore another type of circuit breaker called oil circuit breakers, OCBs. Welcome back. What do we actually mean by oil circuit breakers, OCBs? An oil circuit breaker is a type of electrical circuit breaker that uses oil as a dielectric medium to quench the arc and provide insulation between the contacts. It is designed to interrupt electrical power circuits under normal and fault conditions, ensuring the safety and reliability of the electrical system. Oil circuit breakers have been widely used in power distribution systems for many years, particularly in medium and high voltage applications. The principle of operation of an oil circuit breaker is based on the ability of oil to quench the arc that forms when a circuit is interrupted. When a fault occurs in the electrical system, the circuit breaker detects the fault and initiates the opening of the contacts. As the contacts separate, an arc forms between them, which is then quenched by the oil. The oil serves as both an arc-quenching medium and an insulating medium, allowing the circuit breaker to interrupt the circuit safely and reliably. Let us take a closer look at the arc-quenching process, the function of oil in circuit breaker operation. Please, if you are not familiar with power system arc, you can check out my video on that, through the link in description box below. It will give you an insightful thought about circuit breakers' behavior. So, let us proceed. The arc quenching process is the heart of an oil circuit breaker's operation. When a fault occurs, the circuit breaker detects the fault and initiates the opening of the contacts. As the contacts separate, an arc forms between them. The arc is a high-temperature ionized gas that can cause damage to the circuit breaker and other equipment. The oil in the circuit breaker plays a crucial role in quenching the arc. When a circuit breaker interrupts a circuit, the arc quenching process unfolds in several stages. As the contacts separate, an arc forms between them. As the contacts move further apart, the arc stretches and elongates. The oil surrounding the contacts then insulate and cools the arc, reducing its temperature and energy. At the same time, the arc is extinguished, and the circuit is safely interrupted. So, this is how oil circuit breakers operate to protect our power system. Dear friends, if you are new to my YouTube channel, please support the channel by liking and subscribing to the channel. You can also hit the subscription button to stay updated in all my latest videos on power systems. Thank you for your support. Let us continue. Having known how oil circuit breakers protect our power system, let us now analyze some factors affecting performance of oil circuit breakers. The performance and reliability of an oil circuit breaker are crucial to the safety and efficiency of electrical power systems. Several factors can impact its operation, and it is essential to understand these factors to ensure optimal performance. These include the followings. 1. Oil quality. The quality of the oil used in an oil circuit breaker is critical to its performance and reliability. The oil serves as both an arc-quenching medium and an insulating medium, and its properties can significantly impact the circuit breaker's operation. Factors such as oil viscosity, dielectric strength, and contamination can affect the circuit breaker's ability to quench arcs and interrupt faults. Regular oil maintenance, including testing and replacement, is essential to ensure the circuit breaker operates reliably. 2. Contacts design. The design of the contacts in an oil circuit breaker plays a crucial role in the arc quenching process and overall performance. The contacts must be designed to withstand the high temperatures and stresses associated with arc quenching, and their shape and material can impact the circuit breaker's ability to interrupt faults. Proper contact design can help ensure reliable arc quenching, reduce contact wear, and prevent faults from escalating. 3. Circuit breaker design. The design of the circuit breaker tank, insulation, and other components can significantly impact its performance and reliability. Factors such as tank size, insulation material, and component selection can affect the circuit breaker's ability to withstand fault currents, operate reliably, and maintain its dielectric properties. A well-designed circuit breaker can ensure reliable operation, minimize downtime, and reduce maintenance requirements. 4. Oil contamination. Contamination can significantly impact the performance and reliability of an oil circuit breaker. Moisture, dirt, and other contaminants can compromise the oil's dielectric properties, affect the contact surfaces, and lead to faults or failures. Regular maintenance, including oil testing and replacement, can help prevent contamination and ensure reliable operation. 5. Operating conditions. The operating conditions of an oil circuit breaker, such as temperature, humidity, and fault current, can significantly impact its performance and reliability. Extreme temperatures, high humidity, and fault currents can affect the circuit breaker's ability to quench arcs, interrupt faults, and operate reliably. Understanding the operating conditions and selecting a circuit breaker designed for those conditions can help ensure reliable operation and minimize downtime. So, understanding these factors and taking steps to ensure optimal performance can help ensure the safety and reliability of electrical power systems. As we have explored factors affecting oil circuit breakers, let us analyze the two main types of oil circuit breakers. 1. Bulk oil circuit breakers. These type of oil circuit breakers use large volume of oil to quench the arc and provide insulation when contacts are separated. The contacts and arc quenching mechanism are immersed in a tank filled with oil, which serves as both an arc quenching medium and an insulating medium. This design is simple and robust, making it suitable for high voltage applications. Bulk oil circuit breakers have been widely used in electrical power systems for many years, and they offer several advantages that make them a popular choice for many applications. Some of the key benefits include: 1. Simple and robust design. Bulk oil circuit breakers have a simple and robust design, which makes them easy to understand and maintain. The design is based on well-established principles, and the components are rugged and reliable. This simplicity also makes them less prone to faults and failures, reducing downtime and increasing overall system reliability. 2. High reliability. Bulk oil circuit breakers are known for their high reliability, which is critical in electrical power systems where downtime can have significant consequences. They are designed to operate in a wide range of conditions, including high fault currents, and they can withstand the stresses associated with fault clearance. 3. High short circuit currents handling. Bulk oil circuit breakers are capable of handling high short circuit currents, which makes them suitable for applications where fault currents are high. They can interrupt faults quickly and safely, reducing the risk of damage to equipment and ensuring the safety of personnel. Despite the fact that bulk oil circuit breakers offer several advantages, they also have some limitations that need to be considered. Let us analyze the limitations of bulk oil circuit breakers. Some of these drawbacks include the followings. 1. Large oil volume. One of the most significant disadvantages of bulk oil circuit breakers is the large oil volume, which can cause fire hazard. The oil can ignite if it comes into contact with an electrical arc or hot surface, causing a fire that can spread quickly. This risk can be mitigated with proper design, installation, and maintenance, but it remains a concern. 2. Risk of oil leakage and contamination. Bulk oil circuit breakers are also at risk of oil leakage and contamination, which can compromise their performance and reliability. Oil leaks can occur due to faulty seals, corrosion, or other factors, and contamination can occur due to moisture, dirt, or other substances entering the oil tank. 3. Heavy and bulky design. Bulk oil circuit breakers are heavy and bulky, which can make them difficult to transport and install. The large oil volume and robust design require a sturdy tank and supporting structure, which can add to the overall weight and size of the circuit breaker. So, these are the basic limitations of bulk oil circuit breakers. Next type of oil circuit breakers we will discuss is minimum oil circuit breakers. They use a small volume of oil to quench the arc and provide insulation between the contacts. The oil is contained in a small chamber, or tank. The contacts and arc quenching mechanism are designed to minimize the amount of oil required. This design is more compact and efficient, making it suitable for medium voltage applications. The reduced oil volume reduces the risk of fire and oil leakage occurrences, and the smaller design makes it easier to install and maintain. One of the key differences between the bulk oil circuit breakers and minimum oil circuit breakers is the amount of oil used. Bulk oil circuit breakers require a large volume of oil, which can be a concern in terms of safety and environmental impact. Minimum oil circuit breakers, on the other hand, use a much smaller volume of oil, which reduces the risk of oil-related problems like fires. In terms of design and construction, bulk oil circuit breakers are often simpler and more robust, whereas minimum oil circuit breakers are more complex and sophisticated. The design of minimum oil circuit breakers requires careful consideration of the arc quenching mechanism and insulation requirements, as well as the minimization of oil volume. When it comes to applications, bulk oil circuit breakers are often used in high voltage applications, where reliability and simplicity are critical. Minimum oil circuit breakers, on the other hand, are more suitable for medium voltage applications, where compactness and efficiency are important. So, these are all about types of oil circuit breakers. Having known what minimum oil circuit breaker is, why are we interested in this type of oil circuit breakers? What are the benefits of minimum oil circuit breakers? Minimum oil circuit breakers offer several advantages that make them a popular choice for many applications. Some of the key benefits include the followings. 1. Reduced oil volume. One of the most significant advantages of minimum oil circuit breakers is the reduced oil volume. Having less oil, the risk of fire and leakage is significantly reduced, making them a safer option for many applications. This reduced oil volume also makes them more environmentally friendly and easier to handle. 2. Smaller and lighter design. Minimum oil circuit breakers are designed to be compact and efficient, making them ideal for applications where space is limited. Their smaller size and lighter weight also make them easier to transport and install, reducing the overall cost of the project. 3. Lower maintenance requirements. Minimum oil circuit breakers require less maintenance compared to bulk oil circuit breakers. With fewer components and less oil to maintain, they are less prone to faults and failures, reducing downtime and increasing overall system reliability. Final benefit we will look at is environmentally friendly. Minimum oil circuit breakers are a more environmentally friendly option due to their reduced oil volume. This makes them ideal for applications where environmental concerns are a priority. They also reduce the risk of oil spills and leaks, which can harm the environment. Now that we have discussed the advantages, let us examine the drawbacks of minimum oil circuit breakers. Some of these key limitations include the followings. 1. More complex design and construction. Minimum oil circuit breakers have a more complex design and construction compared to bulk oil circuit breakers. This complexity can make them more challenging to manufacture and maintain, requiring specialized knowledge and skills. 2. Higher cost. Minimum oil circuit breakers are generally more expensive than bulk oil circuit breakers. The reduced oil volume and compact design require more advanced materials and manufacturing techniques, which can drive up the cost. However, The benefits of reduced maintenance and increased safety may outweigh the higher upfront cost. Last drawback we will look at is specialized knowledge and skills. Minimum oil circuit breakers require specialized knowledge and skills to maintain and repair. This can be a challenge for some users, particularly those without experience with these types of circuit breakers. So, these are the major limitations for the minimum oil circuit breakers. Having analyzed the types of oil circuit breakers, let us explore the applications of oil circuit breakers. Oil circuit breakers have been a good choice in electrical systems for years, particularly in medium and high voltage applications. Their reliability, simplicity, and ability to handle high fault currents make them a good choice for many industries. These circuit breakers play a crucial role in power distribution systems, protecting electrical equipment and ensuring a reliable power supply. They are commonly used in substations to safeguard transformers, generators, and other critical equipment. Additionally, they are used to protect distribution lines, guaranteeing a stable power supply to consumers. In industrial settings, oil circuit breakers are widely used to protect electrical equipment and maintain a reliable power supply. They are found in manufacturing plants, oil and gas facilities, mining operations, and chemical plants, where they withstand harsh environments and corrosive conditions. Lastly, utility power systems also rely on oil circuit breakers to protect electrical equipment and ensure a reliable power supply. They are used in transmission lines, generation stations, and sub-transmission systems to guarantee the stability of the power grid. So, these are the areas where oil circuit breakers find its applications. In conclusion, oil circuit breakers are widely used in power distribution systems, industrial applications, and utility power systems due to their reliability, simplicity, and ability to interrupt high fault currents. Their applications range from substations and distribution lines to manufacturing plants, oil and gas industry, and utility power systems. So, this is all about oil circuit breakers. Here, we bring the class to an end. If you like this tutorial, please like and subscribe to the channel for our upcoming videos on power systems. In our next class we will discuss hexafluoride circuit breakers, which is also known as SF6 circuit breakers. Thank you and have a nice day.